Today we're talking about two-way tables. We're going to start with a Venn diagram. You've seen Venn diagrams before. This one, for instance, shows students who take a foreign language and the number of students who play a sport. Some of them take a foreign language but don't play a sport. Some of them play a sport but don't take a foreign language. And some do both. A two-way table shows us the data that falls under those two categories. So here I have the sport categories going across the top, plays a sport or does not play a sport. Going down the side I have takes a foreign language and does not take a foreign language. And then we have some spaces for some totals. So we're going to hurry and fill this in. First of all, this first box are for all the students who take a foreign language and play a sport. So if I go back and look at my Venn diagram, where would I find those students? Right? How many students do both? Those are the 14 students here in the middle. So in this box, I'm going to put, oops, let me fix the pen here. I'm going to put those 14 students. Then in the next box, I want the students that take a foreign language but don't play a sport. So if I look at my Venn diagram, that would be these 23 kids over on the left. Now be careful when you look at these numbers, because if I'm just looking for how many students take a foreign language, that's not just the 23 kids. That's everyone in the yellow circle. That would be 23 plus 14. 37 students take a foreign language. So I have to be a little bit careful. But for the box we're looking for, that's the 23 students that take a foreign language but don't play a sport. So 23 for a total of 37 students that take a foreign language. Then I have students who play a sport but do not take a foreign language. That would be the 10 people in blue. So then I've got 10 over here. And our last spot right here are the kids who don't do either. Does not take a foreign language, does not play a sport. In our Venn diagram, it doesn't really show us how many kids don't. They would be on the outside of the two circles. So since I don't have any information for that one, I'm just going to put a 0 there and call it good. And then I'm going to add up some more totals. How many kids do I have in the play a sport column? I have 24. How many kids in the do not play a sport column? 23. And how many kids in the do not take foreign language column? Row, that would be 10. And if you add down the total column and add across the total row, you should get 47 in both directions. There's 47 kids in this example. This is a two-way table. So now we're going to write down a couple of quick definitions. First, we have joint probability. Probability is like the chances of something happening, right? Joint probability are the numbers in a two-way frequency table that depend on more than one category. So that's why it's called joint, is because it joins together two categories. Okay, those are the middle squares on my diagram. So if I'm looking for the probability that I have a female that works at the hospital, so here I have a new two-way table, right? I can look down here and I look for the females that work at the hospital. I have 52 of those. But to turn it into a probability, I say that there's 52 girls that work in a hospital out of all 300 people. So this total right here is going to be really important to my probabilities. The second probability that if I choose a person out of this group, that it's going to be a male that works at the library. Well, I have 27 men that work at the library. So 27 out of 300 people. 27 out of 300 people work at the library and are boys. That's joint probability. Then I have something called marginal probability. And those are numbers that only represent one category, and those are going to be my category totals. So for instance, if I want to find the probability that if I pick someone off this chart, they work at the animal shelter, I look at how many people just work at the animal shelter, right? By the way, they're called marginal probabilities because I can find the numbers in the margins, right? Those are our margins. So people that work at the animal shelter, there are 141 of those out of all 300 people. And the probability that if I choose a person from this group and they happen to be a girl, well, there are 156 females in this group out of all 300 people. Those are marginal probabilities. And then we have a conditional probability. It's kind of like our other probabilities, except now we're going to put a condition on my total. We're going to know part of the information already. So let me show you what that looks like. This first probability that I'm looking for reads the probability of a person working at the animal shelter if they are a female. So this second part, them being a female, that would be my given part. I already know that it's a girl. What's the probability that this girl works at the animal shelter? Now the reason why this is different than the joint probability is I'm not talking about all 300 people anymore because not all 300 people are girls. I'm just talking about the girls, so my denominator is now going to be those 156 girls. And how many of those girls work at the animal shelter? 63 of them. This is going to be my conditional probability. The second one says, what's the probability that I have, or that if I pick a person from this group, that it's a male if they work, or given that they work at the library, or if they work at the library. So now the second part of my conditional probability says, I know that they work at the library. How many of those people are men? So how many work at the library? 68 of them. I'm not talking all 300 people anymore. I'm talking the 68 people that work at the library. And how many of those are men? 27. The reason that conditional probability is so different is because when I turn these into percents and decimals, they're going to have a much different percent than if I put that over 300. So once more, let's just go through a couple more quick examples. First of all, what's the probability of picking a person that's male? Is that a joint probability, a marginal probability, or a conditional? That would be marginal since it's only talking about one category. So there are 144 males in this group out of all 300 people. What's the probability of working at the hospital? For this group anyway, 91 people work at the hospital out of all 300 people. Probability that if I pick a person from this group, they're a girl who works at the animal shelter. Well, there's 63 girls that work at the animal shelter out of all 300 people. What's the probability that a person is a male who works at the animal shelter? There are 78 boys who work at the animal shelter out of all 300 people in this group. 3 and 4, those are our conditional probabilities. So remember, the second part determines our denominator. So how many males are there? There's 144. And how many of them work at the library? 27. On this last one, how many people work at the hospital? 91. And how many of them are female? That would be 52 out of 91 people. Last but not least, we're going to take our two-way table and turn it into a frequency table. A frequency table is where I turn all these individual frequencies, these are called frequencies, into decimals. So to turn these into decimals, I'm going to take each number and divide it by my total number of people in the group. So I'm going to take all of these numbers in here and divide them by 300. So 78 divided by 300 is 0.26. So I'm going to put a 0.26 in that square. Or in that spot. I guess it's not a square. Then I'm going to take 63 and divide it by 300. And I'm going to put 0.21 in that square. Or spot. I'm going to do the same thing with all of those numbers. I'm going to divide them all by 300 until I have decimals. Sometimes you'll see these written as percents. So like the males that work at the animal shelter, 26% of my group are males that work at the animal shelter. 21% of my group are females who work at the animal shelter, and so on. I still have decimal totals, right? But now look at my final total. 1. In a frequency table, that spot will always be 1, which when I convert that to a percent is 100% of my group. That's what a frequency table looks like. Make sure to bring any questions that you have. Don't forget to take the online quiz, bring your notes to class, and have a great day. I'll see you later.